Welcome to Engineering Mechanics. So here is a question of equilibrium of a rigid body. So the question says lever AB is hinged at C. So this is where it is being hinged and attached to a control cable at A. So this is the control cable A. Don't forget this is a control cable A. Determine the tension in the the question has determine the tension in the cable. B, the reaction at C. So that means in this case the question is asking us to determine the tension in this cable, this is the cable, and the reaction at A. So we are determining the reaction at this point. Don't forget, since this is a cable, we are only meant to have just a single reaction, and since this is a hinge, so that means we are meant to have two reaction, one in this sense and the other in this sense. Sorry, the other in this sense. So let's draw the free body diagram of this particular stuff. So let's put it down. So now don't forget, let's draw this slant one. So that means here we are having this. We are having this is our A. So this is where the inch is. So this is our B. Then this is our C. Now don't forget this is so let's see at this point to this point here we are having this to be our, let's say this is our D. So don't forget from here to here we are having this, from here to here, and also so now let me use this to write out all the forces we are having. Now we are having a force here, don't forget. Then we are having a tension in this case. So that means in this case the tension will be having this component and this component. Don't forget the tension if you want to expand it. So that means we'll be having this component and this component. Now don't forget, now the reaction at C, don't forget according to the Newton's third law of motion, for every action there must be an equal opposite reaction. So since these are acting down, so that means our first reaction in the y-axis, don't forget, is a plane. So that means we are having two reaction, and then this at this point, that means we are having this. So that means we are having this reaction. Don't forget this is the free body diagram of this. So don't forget, according to the question, from this point also it is being inclined at 20 degrees here. Then from here to here is 15 inches, 15 inch. Then from here to here is 10 inch. Also don't forget, from this point here, let me use this, to this point T here, the height, that's what, 12 inch. Let me use this in this case, sorry, let me use this in this case, 12 inch. And also what am I missing? 75 pounds. Yeah, 75 pounds. So that means we're having 75 pounds here. Now as you can see, here is the free body diagram of this particular question. So now how do we now go about this? Don't forget how many problems are we having here? We are having 1, 2, 3, 4. We are having 4. Don't forget this is the free body diagram of this particular question. So but according to this is a 2D mechanics. Don't forget here we are having 4 problems but 3 equations. Don't forget the first equation, we know our summation f of x to be equals to 0, summation f of y to be equals to 0, and summation of moment about any point here, which is this point C, is equals to 0. We are using C. Now for this thing to be actually simpler, so let me indicate the direction which I'm using. So I'm using this direction, which is this is my y, then this is my x. I'm using this dimension or direction rather. So So now the first thing is, don't forget this particular tension in AD. We can't say this tension is going neither x direction nor y direction. So we have to have a way to solve it. So let me draw. Don't forget this is a hinge pin. So that means we can actually split this into two equations. So that means we'll be having one from this point here to the hinge here. That's one. And other one from this hinge to B. That's another equation. Making two equations. Don't forget this is a C. This is our C. That means the action here. Okay. That means we are good to go. So from here, so let me now bring from A to C outside. Let me bring from A to C. So that means we'll be having, so let's do this from A to C. That means we'll be having this in this direction, like this. Don't forget, okay, let me just extend it like this. This is my C, this is my E. And don't forget to D also, the D. Sorry, the D is here, somewhere here. So that means we'll be having this in this, this in this action direction, and also this is making an angle of what, 20 degree with the ground. Don't forget, according to the diagram. And also, since this is making an angle of 20 degree to the ground, don't forget this is, let me use my pen to draw the tension out. So this is the first tension here, the other tension here, which is this. Then this is in this. The tension here is acting in this direction. So, my bad. So, the tension here is acting in this direction according to math knowledge. So, let's say we elongate this. Don't forget, since this is the force, the line of action of this force will be in this action. In this will be in parallel to this force. Don't forget, we can actually do this. This will be like more like my probably y, and this will be your x. Don't forget, so we can actually do this, extend this out. This is our force here, the one and the other one in this aspect. So don't forget, this is like a transversal line that cut through this particular 2 points. So that means if here is 20 degree, here will be what, 20 degree, meaning corresponding angles are what, are equal. So since we've actually identified that from here to here is 20 degree, now don't forget, according to the question gave us the length from here to here to be equals 10 inches. So and we already know from here to here to be equals 12 inches. Sorry for the diagram, this is not bent, it's straight actually, 12 inches. So now we can actually resolve this particular one into x and y component. Let me bring the aspect of the 10 inches outside in this manner. So that means we'll be having, for the 10 inches we'll be having this, then this. So that means we'll be having 10 inches, here is 20 degree. So that means here is opposite, so that's 10 sine 20 degree. Then here is adjacent, that's 10 cos 20 degree. So as you can see, we've actually resolved this line here. But don't forget, we haven't determined this angle here. Let's call this our beta. So don't forget, we haven't determined this angle here, but we are still coming there. Now, let's go back to this actual free body diagram that I drew earlier. So from here, don't forget that according to what I did, I said according to this diagram that I bring out, now I said this is 10. I said this is 10, but okay, wait. So let's do this. Let's do this for better clarification. So this is 10, right? So that means here is 20 degree. Don't forget, with this diagram that I bring outside. So that means I said here is what, 10 cos 20 degree. Then here is 10 sine 20 degree. Don't forget, the total height from here is what, 12 inches. So let's actually calculate the one of 10 sine 20 degree. So that means 10 sine 20 degree is what, 10 times sine of 20 degree, which is 3.42. So that means we can say this is 3.42 inches. And here is what? 10 times cos 20 degree, which is 3.9, sorry, 3.4, yeah, sorry, 9.4 rather. So this is 9.4 inches. So now, as you can see, the diagram is getting clearer. As you can see, we can now say, don't forget, since we've already identified, let me draw this out. Okay, let's use this. Since we've already identified this, so that means we know from here to this point is what? 3.42. Now, this point to this point will now be 12 minus 3.42. Since we already know the total length here is what? 12 inches. This 12 inches that I wrote here, let me bring it out here. 12 inches. So that means we can say for year to year, it will now be what? Is 8.58 inches. Now, don't forget, we can actually bring this back to the diagram. So you can see this thing is getting more interesting. You can see from here to here is what? 8.58 inches. Now, let's bring out the parts of A and C again. So, okay, bring the A out. As you can see, the game is getting more interesting. So let's bring the A out. So we can actually say from here to this C is this. Then this is the force here, which is being inclined at here. Sorry, let's put it here. Let's put it here. So which is being inclined at here 20 degree. Then we know from here to here to be what? 3.42. And another force that was being acting here, which is then from here to here is what? From here to here, 8.58. Now, don't forget here like this that we've actually calculated, which is 10 cos 20. That's what? 9.4. Don't forget this is 9.4. So we can actually say here is 9.4 inches. Don't forget here is 10 inches. So that means we can actually get our beta in that direction, in that aspect. So that means we know our tan beta to be equals to y over x. This is our y, this is our x. So that means beta is equals to tan arc 8.58 over 9.4. So that means we'll be having 8. Means beta is 42.38. So that means we'll be having beta to be equals to 42.39 degree. So that means in this case we've actually gotten our beta to be 42 point to be equals to 42.39 degree. So now from here, let's now redraw this particular free body diagram. We don't actually need this from the source anymore. So let's redraw this particular free body diagram with all this inside. So now don't forget this, we will now be having from this to this, then this is our C, then this is A, this is B, and from here to here is what? 15 inches. Then don't forget there is, so let's write out all those forces, one in this aspect, other one at this aspect. So we can say this is our CY and this is our what? CX. So for here we'll be having this to be this in this direction, then this to be in this direction. Then let's see, this is the point D. So I'm bringing out everything. So that means from here to here is D. So that means we know from here to here to be 42.39 degree. Then here is what? 20 degree. Then here is also what? 20 degree. Then from here to here is what? 3.42. Then here is what? 10 inches. 10, I'm writing 10 here, 10 inches. Then here is 9.4 inches. Then from here to here is what? 8.58 inches. Then the total length here is what? 12 inches. So now, as you can see, and we don't forget we have a force acting in this direction. So that means if we want to resolve this 150 inches, this is 20 degrees. So that means we'll be having 15 sine 20 degree here, and also here will be what? 15 cos 20 degree, because we can't say this 15 inches is in x or y direction. Don't forget we are still using this direction, y and x. So now, since we've actually identified this problem, so the first thing is, now let's calculate. The first question is asking us to calculate the tension in the cable. So that means we are meant to determine the tension here in this particular cable. So our first approach will now be, for us to get the tension, we have to eradicate this particular cx and cy for us to be able to get this tension. So the first thing we do here is we take our moment about point C, and we know summation of moment about C is equals to what? 0. Since we already know the summation of moment about C to be equals to 0, now don't forget this force cy and cs, they are acting at a point, so their moment is actually 0. That means we eradicate this cx and cy. So now let's take this b with respect to C. Now don't forget, here we are having 75 pounds here. So that means here we will be having 75 times, this is the force. The force can actually elongate here, so the perpendicular distance of this force with respect to this is this 15 cos 20 degree. So now, which direction? Don't forget, let's take our counterclockwise direction to be what? Positive. So which direction is this? This is in clockwise direction. So that means we'll be having what? A negative answer here, minus 75 times cos of 15 cos 20. Now this one also here, this one that is also here, this is, let's call this our tension in y, then this is our tension in x. So let's take the one of our tension in x, our tension in x. Yeah, so that means our tension in x with respect to this is our tension in x. With respect to this, it will be tx times this, your perpendicular distance. This is the perpendicular distance of it. So that means we'll be having tx times 0.42. Don't forget our tx here is what? Tx. Our tx, let's actually resolve this tx and ty. So that means our tx here will be opposite, here will be what? Adjacent. With respect to that, here will be our opposite, here will be adjacent. So that means our t, that's t cos beta, then this will be what? T sine beta. So that means we'll be having this. Then don't forget, this will be going in this direction, which is what? The counterclockwise way. And our counterclockwise moment is what? Positive. So that means then the third one, which is this, we'll be taking our moment. This is the force. The perpendicular distance of this force is from here. This is our y. So the perpendicular distance of this y is from here to here, which is your what? 9.4. So that means we'll be having then this plus, don't forget, this will be in counterclockwise direction. This will be ty times 9.4, which is equals to what? 0. So from here, so that means we'll be having, don't forget our tx is what? T cos beta, then this will be what? Times 3.14 plus t sine beta times 9.4 should be equals to, then this 15 times cos 20 degree times 75, which is equals to 1057.15. So from here, don't forget this will now be t cos of 42.39 times 3.42, this is in this bracket, plus t sine of 42.39 times 9.4 should be equals to 1057.15. So now from here, so let's go about this. So that means we'll be having cos 42.39 times 3.42. So that means we'll be having 2.5259, no rubber 92, no rubber approximation here, plus 20t to be equals to 1057.15. So that means our t, so we will do the summation of this plus 2.52592, that's 8.863. So then 1057.15 divided by what we get. So that means our tension in AD, don't forget that's what we are calculating, is what 119.27 pounds. Don't forget we are dealing with pounds, LB. So that's for the tension in AD. Now the next thing that we are now meant to do is, so let's take the summation of f of x. Summation of f of x to be equals 0. Now the first one we are having our cx. Don't forget, going towards the negative of x, so that's minus cx. Then the next one we are having our tx, tab of x, going towards the positive, plus tad of x is equals to 0. So that means our cx will now be equals to the tension which is of x, which is t cos beta. So that means our cx is equals to t cos beta. Our t is what? 119.27 times cos of 42.39 degree. So that means we'll be having 119.27 times cos 42.39. So that means we'll be having 88.09 pounds. So the next one, so let's take the summation of force at y to be equal 0. So that means here we will be having the first one. Don't forget this at b is going downward, that's minus 75 pounds. Then this one plus cy. Then this is coming down, minus t sine beta. Don't forget that's our ty is equal to 0. So that means our cy is equal to 75 plus t, which is what? 119.27 times sine of 42.39. So that means cy is equal to, so that means our cy is equal to, let's calculate that now, 119.27 times sine of 42.39, that's 80.4 plus 75. That means we will be having 155.41 pounds. So for us to now get our reaction as B, don't forget the reaction at C rather will be this. Don't forget, in normal sense will be in form of this. So that means we can bring this out. So let's use just a small side here, since what we are doing is not that many. So that means we can bring this diagram in this sense. Don't forget, sorry. So that means our diagram will be in this sense. Don't forget, this is how we drew it. Then the resultant will go in this manner, y, then x. Same thing, you get. So that means this is our cy and this is our cx. So that means here is what 115.41, and here is what 88.09. So that means our c at r will be equals to square root of cy square plus cx square. So that means our cr will be equals to 8.63 pound. Now that's all. So you can actually get the angle in which your cr is inclined with this. Let's call this theta. So you can just say your tan arc of theta, your tan theta is equals to y over x. So that means your theta will be equals to the shift tan arc of your y. Your y is what? 155.41 all over 88.09. So you take the shift tan arc of this. So let me use calculator to solve this so we can see shift tan arc of 155.41 over 88.09. So that means this is being inclined, your resultant, your reaction at R is being inclined with x at what? 60.45 degree. Thank you very much. Here comes to the end of these problems. Make sure you subscribe to my YouTube channel and always turn on the notification button. Thank you guys.